Assalamualaikum. Welcome to the Eduverse, a universe of learning. I hope you all are doing so well with in a good health and joy with your family. Today we are going to talk about a very important topic of the physics, that is dimensions and dimensional analysis. It's actually understanding the language of physics. So let's talk about like what is the dimensions and what is the dimensional analysis in the physics. First of all, we should to know that what are the dimensions actually. The dimension represents the physical nature of the quantity, like it shows the physical nature of the quantity, like what is actually it is made it of, and show how it depends on the basic quantities like mass, length, and time. And then the dimension will show that how the quantity is dependent on mass, length, and time. That's what we will show by the dimensions. Here we have some examples of the dimension of some physical quantities like speed, meter per second we have. So for meter it's L, and for second it's T, time. So time inverse means that it's actually beneath that in the denominator, but when we move it upside, it will become the inverse. Force ml t minus square, energy ml square t minus square. So here these are some examples. We will discuss about the examples and how to find the dimensions of different physical quantities. We'll do in a very detail in the upcoming lectures, and we'll deep dive about it. Here we have some other different examples of the fundamental and derived quantities. Mass only m, length L, and t, time. Here are the derived quantities, like for fundamental combined together and makes derived quantities, speed, force, energies, all that is all are the examples of derived quantities dimensions. What is dimensional formula? Actually, for finding the dimension of physical quantities, we will use a dimensional formula. So that's actually the expression showing how and which of the fundamental quantities are used to represent the derived quantities. As in the previous slide we used that, we see that like for dimensional formula actually saying us like which type of fundamental quantities are to be choose for expressing about the derived quantities dimensions. So here we have L for length. It's actually for the is actually the fundamental, and there we have the time that is actually fundamental. So we are combine them together to make the speed dimension. So that's actually the formula for representing the for representing like how the which are which how and which the fundamental quantities are used to represent the derived quantities. It's called its dimensional formula. Example, for the force we have the dimensional formula mlt minus square. So this is the example of the energy as well. So this is the dimensional formula. Application of dimensional analysis, like if we are doing a dimensional analysis, like what are the actually benefits and why we are doing it, or where we can use it. So there are some bullet points about that. Check the correctness of the equation, like the equation is actually correct or incorrect, so we can check it by the dimensional formula and dimension. We will discuss about it in a very detail in the upcoming lectures, inshallah. Derive the relation between quantities, like if we have two type of if we have an equation of the quantities, then we will derive the relation between like how they are actually related with one another. So we can use the dimensions for that. So that's actually the application, one of the applications of the dimensional analysis. Convert units. Dimensional enable us to convert the units of the physical quantities. So that's also the application. Understand the proportional relationships. Proportional relationships means that, like how the different quantities, how the different physical quantities are proportional with one another. Either they are inverse proportional, or either they are the direct proportional with one another. So the dimensional will allow us and will enable us to know about all these proportional relationships of different quantities or different physical quantities, and will understand about it. So these are actually some applications of the dimensional analysis. Here we have an example, very simple example over here about the checking of the equation, either the equation is dimensionally correct or not correct. Like, it can happen, physical quantity can be correct, but that quantity cannot be dimensionally correct. So that checking will be done with the dimensional formula or the dimensional analysis. We can do that with this example. Let me have an example. The equation of motion S is equal to ut plus 1 by 2 at square. Here u is actually the velocity, okay, and t is the time, half, a is the acceleration, t square, the square on the t. So it's, we have you already know about it. It's the equation of motion. So step by step checking the dimensions. So first of all we will look about the left hand side. Left hand side we have only s. S is actually for the distance. This is mean length. So we have the dimension of length is L, as we have discussed in the previous this. Over here we know that the length, the dimension of the length is actually only L. So that's on the left hand side here we have only D, means that the distance. So L is only the dimension. The main thing we will know about that is to be the right hand side, because we have the little bit of very expression about that side. So let's type about it. The right hand side is actually L, but how? This and this way, from this. Look about it. U means that meter per second, meter, length per second, time, that's the U, multiply by time t. This is about this one term. Now this term, forget about the 1 by 2, I will tell you about it later. First look about this side. This is L meter for meter length, m meter per second square, so the time square, meter per second square, L time inverse square. It shows the acceleration, multiply by time square, we have t square. So over here the dimension is also a square. So now look about it. T inverse only t, base same. Now add up their powers, it will become 0, and that power in 0 will give us 1. Look about this one as well. Minus 2 plus 2 give us 0 in the power, and that power in 0 will give us 1. 1 multiplied by L plus 1 multiplied by L means 2L. 2L, 2 will be left it off, and we will left only with the L. So means that the right hand side is also giving us L dimension, and the right hand side, the left hand side, the left hand side also giving us L dimension, and the right hand side after the derivation also gave us the L dimension. So means that the left hand side is equal to right hand side according to the dimensions on the basis of dimensions. So we can say that yes, this equation is dimensionally correct. We will see that some of the equation may be physically correct, but they are not dimensionally correct, because their dimensions on the left hand side and right hand side might not be equal. So that's why they are physically correct, but they are dimensionally incorrect. So but this equation we have, this equation is dimensionally correct we have. So this is the simple example. I'm telling you again that we will know about the different examples in detail in the upcoming lectures, inshallah. then you can get very easily about that. Limitations of analysis. Everything in this world have some benefits but have some limitations. Limitations is actually not the disadvantages, we can say. Limitations is actually the uh, beyond the approach of something. Like if we cannot say that yes it's a failure or it's like a disadvantage of this. It's like a limitations of this dimensional analysis. So like we have to think about positivity. Sometimes we use this word with the people like that. Oh, that person is so weak in it. He might have some problems. He might have some limitations about it. Yeah, his body limitation. So that's we cannot say that yes, that limitation is actually the failure or the weakness. Limitation is actually beyond that something. Like we cannot approach that. So here also the limitations of dimensional analysis. Dimensional analysis also has some limitation, that is cannot find the constants. As here I have told you that like forget about the 1 by 2, and after the derivation we have the 2l. So I told you that forget about that because it's the limitation of the dimensional analysis. Like the dimensional analysis cannot find about the constants, cannot verify the trigonometric or the exponential equations. If we have some exponential, means that there is an exponent over there in the equation, so the dimensional formulas or the dimensions cannot be able to find about that. And also we have, if we have the trigonometric equations like the sine equation having sine, cos, tangent, so that type of equation cannot be found or cannot be uh, converted or cannot be verified by the dimensional analysis. Only works when the quantities are dimensionally consistent. This is the main point and very important point. Means that it's actually only working for that type of quantities which are dimensionally consistent. If the equation or the properties or the physical quantities cannot be dimensionally correct or consistent, the dimensional analysis will be limit about that. The dimensional analysis cannot find about that, cannot be able to work about that. So these are some limitations of the dimensional analysis. All that about this topic, and we have summary key points what we have studied in this small lecture. Dimensions shows the nature of the physical quantities. In the beginning, as we have told you that, I have told you that dimensional formulas use MLT. MLT is actually the basic units for the formula, for finding the formula of the any physical quantities. Like these three actually roles actually yes, used to verify, convert and derive the relationships. Dimensional analysis used for the verifying either the equation is dimensionally correct or not, for conversions, and for derive the relationship, inverse and proportional relationship, all that something, directly proportional, inversely proportional, all that for we use dimensional analysis. And the main thing, it has limitations too, as everything has. So this is all about for today lecture. Really thank you for watching. If it helped you well, then please like, share and subscribe to Eduverse. Yes, the main thing I always saying that if you have any suggestion, if you have any problem, if you have any type of something you want to tell me, you want to tell me to, for me to improve that, you can comment in the comment box. You are very free to say anything relevant to this topics, and you can ask for any other topic if you have any confusion, and I can create a video for that topic particularly. And also you can also contact me through my personal email I have attached over there in my account, so you can contact me over there and I will respond to you, inshallah. And keep growing, keep improving yourself, always try to seek new things every day, because that will move you, that will make you more improved, And if you are improving yourself every day, that's the real job you are doing. So, thank you so much and Allah Hafiz.